Hello, biochemistry students. So this video will be an explanation for how to calculate the PI. We are studying amino acids and primary protein structure, protein primary structure, and sometimes you can see the primary structure written like this. Those are the one-letter abbreviations for the amino acids. I know. You don't need to memorize those. I'll give those to you on a test. But if you've thought about them, then things can go a little better. One thing you should do right away is write down, the positively charged amino acids. There's 3 of them. And sometimes I think of HAL. HAL is lysine, which is a K. And A is for arginine, which is R, and H is for histidine, which is H. So those K and R and H are going to be positively charged, and there's 2 amino acids that are negatively charged. And actually, they are aspartate, which is D, and glutamate, which is E. So A, B, C, D, and E are used for aspartate and glutamate. Okay, and I actually put those over here. There's 2 amino acids that are negative. And remember, those are actually aspartic acid and glutamic acid. But at pH 7, it's not in the acid form, it's in the negative carboxylate ion form. So that's why we call it aspartate instead. But both are true names for this amino acid. Okay, so D is aspartate, which has a negative charge at physiological pH, right there. Q, what does Q stand for? I guess I need to look that up. GLN. So this N stands for amide, or amine. Oh, weird. It's actually an amide. It's got the C double bond ON. And this does not have any charge on it. Amides are neutral, so we don't have to worry about that one. Serine is an interesting one. It does have an OH. But we never worry about that, the pKa is way up around 16. And remember, pH goes to like 14, so we don't need to worry about that one either. K is special. Where's K? It's lysine. That one's going to be, let's write lysine. That's going to be positive. A is for alanine. Alanine is one of the nonpolars, so we don't need to worry about it when we're thinking about the PI, because what is the PI? The PI is the pH where all of these ionizable groups have a net 0. So we only need to think about ionizable groups, and alanine doesn't have an ionizable group. What does Y stand for? Y stands for TYR, which is tyrosine, which does have a pKa. This is a phenolic OH, and it will have a pKa up around 10. Oh, so what are the pKa's? Let's write that down. The pKa's for, the R group. We're only looking at the R groups now, because these are connected by peptide bonds. That's not what I wanted. Peptide bonds between all of these. And the peptide bonds, remember, are amides, which are neutral. So yeah, don't need to worry about the pKa for those. Let's change back to black, I guess. Okay. Where was I? Oh yeah, pKa's. And these are the pKa's. It's the pKr, right? So for aspartate, it's a aspartic acid, which acids have low pKa, so it's going to be 3.7. No pKa for that one, no pKa. Okay, for lysine, the R group is 10.5, and for tyrosine it's 10. Okay, so there's 3 ionizable R groups. All right, let's remember that since this is a polypeptide chain, it does have an ionizable group on the amino end and on the carboxylate end. So we're going to have to remember those too. What are the pKs for those? We can memorize those as approximately 8.5, and what's on the other side? Is it 3.5? Yeah, 3.5. Where did I get those numbers? Those are on page 21. In the information near the bottom of the paragraph, it says you should use these values for all peptides until otherwise told. It says the N-terminal pKa near 8.5, the C-terminal typically 3.5. So we've got those 5 different ionizable groups. Well, let's write this so it's a little bit easier. We'll do a condensed formula. So down here, if we protonate the amine, we get a positive charge. The aspartate will be aspartic acid. The next one is, lysine. Okay. Lysine will have the N, either positive or neutral. And then we've got tyrosine with an OH. And at the C terminal, the pKa, okay, what are the pKa's again? Let's write them down again. 3.5, 3.7, lysine is 10.5, tyrosine is 10, and the C terminal is 3.5. Whoops, what did I get wrong? Acids, carboxylic acids have low pKa's, amines have high pKa's, so that's up at 8. Maybe I should write that a little better. Kind of messed up. Let me try again. Make that look like an 8. Ooh, okay, there we go. Okay, so it's important to have your pKa's of all your ionizable groups, which will be the N-terminal, the C-terminal, and any ionizable groups on your amino acids, and you can tell which ones those are by they have a pKr on your table. So you can look that up. Okay, to calculate the pI, which is all we're about, we need to find at what pH this polypeptide, or I guess polypeptide actually means it's got more than 20 amino acids. This one's got 6 amino acids, so it's not a pentapeptide, it's a hexapeptide, I guess. Okay, so this hexapeptide. So the way to start is to say, what if we had pH equals 0? Okay, that means every ionizable group that's very acidic, and that means that there's tons of hydrogen ions, so all groups will have a hydrogen ion on them. So if we draw it like that, this one will have a positive charge, and this one will no longer be negative. It'll be COOH. So maybe I should draw that. Okay, we'll have, this one will be positive, this one will be neutral, this one will be positive, this one will be neutral, and this one will be neutral. Okay, so what is our net charge? I wrote that before, and I guess I need to like move it up a little bit. Can I do that? Yes. Okay, so net charge. Okay, let's get back to our pencil. All right. Okay, at pH 0, we've got a positive, we don't have any negatives, so we've got a charge of +2. Okay, the next thing you do is you go to the lowest pKa. We've got 8, 3.7, 10.10, and 3.5. Okay, so at 3.5, we know that when when pH equals pKa, we have an equal amount of the acid form and the conjugate acid form, right? Okay, so that means we're going to have an equal amount of the negative and the neutral. Okay, so at pH 3.5, this one will still be all positive. Ooh, 3.7 and 3.5. Oh my goodness. That's going to be close to about half are still positive and about, I'm sorry, half are neutral and about half are negative now, because we've added enough base to get up to 3.5 that some of them have deprotonated. The base grabbed the hydrogen and made it into the negative charge. Ooh, this one's still a full positive, this one's still neutral, and this one is half and half. 1/2 neutral and 1/2 is negative. Oof. Okay, so that means we've got 2 pluses, so that's +2, and we've got 2 half minuses, so that's -1. So +2 minus 1 is +1. Oh boy. Oh my. What if we go to pH 3.7? We're going to have the same thing, pretty much. Half negative. Half negative. Okay, so we're still going to have about, okay, a +1. Okay, what's our next pKa? Okay, we did that one. The next one up is 8.5. So at pH 8.5, so now we've added enough base that one of these is coming off, and so half of them will be neutral and half will be plus. Here all of them are going to be negative. Here nothing changes. And at 3.5 to 8.5, that means there's so much base that all of the H's go, so that'll be a full negative. So now what's the charge? Okay, those two cancel each other, those two cancel each other, and we've got about a +1/2. Okay, +1/2. We're still in the pluses. We need to go up to the next pKa. Oh. I guess it would be 10, not 10.5. Okay, that's weird. Because tyrosine we usually don't think of as ionizable. So, tyrosine. Where is tyrosine? But it says it has 10.07 compared to the lysine, which is 10.5. You know what? Maybe I should throw out the tyrosine. I don't know. Okay, at pH 10, let's see what happens. Okay, 8.5. Remember, once you get above 1 pH unit, 9.5, 8.5 plus 1 is 9.5, that's where you start getting almost 100%. And we're above 9.5, we're at 10. So the base has removed all of those, so it's now going to be neutral. Okay, the aspartate is going to stay negative. The lysine is, I think I shouldn't have used a tyrosine. Interesting. Let's pretend that we didn't use this one. Let's just say it's alanine. Okay. Yeah, so let's just say there's no pKa, so we'll get rid of this. And that doesn't matter because they were just all. I have messed up because that's not a positive. This one, it's supposed to be a neutral. It's supposed to be neutral because we are only up to 8.5, so it should be neutral still. Okay, so if that's neutral, let's recalculate this. I think that's wrong. We have a positive and a negative, and then we have a negative, -1 plus half would be -1/2, which is what I was thinking we should get, but I wanted it to be usually we have a positive 1/2 Yeah, it's interesting that these are so close together. So here's what you do with PI. I'm going to change my color. Okay, when the polypeptide chain or the amino acid has a net 0 charge, all the positives and negatives cancel each other out, then the pH equals the PI. The PI is the pH when the polypeptide chain has a net 0 charge. This is useful when you're doing gel electrophoresis because the proteins will not move towards the cathode or the anode because they have no charge, no net charge. Okay, so that's why we're calculating the PI. So the PI is where the polypeptide chain is neutral. It's not positive, it's not negative, it's right in between, where the net charge is 0. So usually we do the average because we're halfway between positive 1/2 and negative 1/2. But here, we're, let's look at a number line. Here's 0, here's negative 1/2, here's positive 1/2, and here's 1. Okay, so halfway in between would be positive 1/4? No. Yeah. But we want to be at 0, which is and get a different color out. So if we do let's get rid of this. We didn't do that one. So at positive 1 we have 3.7 and at negative 1/2 we have 8.5. So we want to be 1/3 of the way or 2/3 of the way up. So let's add them. Can we add them and divide by 3? 8.5 plus 3.7 is and then if we divide by 3, 12 divided by 3 is about 4. No, that doesn't work. Did I add right? If we divided by 2, we'd get about 6.1. No, I don't think we can do it that way. We have to guess. Where would this be? Boy. What is your guess? 3.7 is somewhere near 4. 5, 6, 7, 8. So 6 is about halfway. Yeah, 6.1 is halfway in between. We need to be a little bit more than that. How about 7? Should we guess that the PI is about equal to pH 7? I think so. Because somewhere in between here is, and it's kind of closer to this pH. So I'm going to go with the PI equals 7, about 7. That's how we figure it out. So you've got to know your ionizable groups, get them memorized, know that aspartic acid is aspartate, know that you've got to figure out the pKr's, and you get those off the table. Memorize that the N terminal is 8.5 and the C terminal is 3.5. Okay, then you've got to start at pH 0. Figure out what the charge will be on all of the ionizable groups, including both the N terminal and the C terminal. Calculate the net charge. And then you just keep on moving up to the lowest pKa and the next lowest pKa. And you think if the pH equals that, then you're going to have half of those ionizable groups will be protonated, half will be deprotonated. Think about what the charge is for both of those. That can be confusing. And then once you switch from positive to negative, that's where you've got to take the average or find what is the pH halfway in between, or in this case, 2/3, 1/3 of the way in between. And when the charge changes from positive to negative, that's in between there is where the 0 charge is, and that's where your PI is. All right. Oh, I hope this wasn't too long, and I'm sorry that I did a problem before. I did the skills exercise, which is on page 24. And then I changed it up a little bit, and I thought I hadn't changed it enough so that it would be a different problem, really, but it ended up being a little different problem. So I think I made this is harder than you will see on a test, and so if you can do this, then you can finish the chem activity. Pages 21 through 23, the last 3 pages of the chem activity, I've just explained to you how to do it. So I hope that you have fun figuring out how to finish the chem activity, and that you, if you get stuck, you could reach out to one of your classmates, your study partner, or myself. Send me an email, let me know where you're getting stuck, and I'll help you.